folks. Well, this time around, let's talk about debugging, all the fun and joy that comes along with that. So we know it's inevitable. We know bugs are going to happen. We have to have, I guess, a plan for dealing with them. So, again, it's part of life, right? If you're going to write a lot of code, you're going to have bugs, and you're going to spend a good chunk of time debugging. And it's going to be incredibly satisfying when you solve one, and it's going to be incredibly annoying until you find what the problem happens to be. So I just want to talk about a few of the habits and techniques that you can use to try and make it a little more efficient and a little less painful. So there's a few coding techniques that we can try and adopt to try and minimize the stress when we get into a debugging situation. So things we can do with the code to make the code a little bit more suitable for debugging. We'll talk about tools that we can use and how to use them. And we'll talk about just techniques and strategies. So most of this is pretty common sense, but there might be a couple of things that help out in here. So obviously it's easier to debug if we write code that's easier to debug. Right? So good comments, clear layout, clear identifiers, so that as you're going through it, you can see the problems, figure out what's going on. Again, the comments should be something that's pertinent to the code, up to date, that sort of thing. The identifier names should be reasonable, not something misleading, not AA and BB and CC. The layout should be clear. It should be easy to follow visually, right? You've got white space breaks between different portions of the code so that you can just eyeball a particular section of the code. You've got good indentation so it's clear what's inside what. Again, if you've got a decent layout, that goes a long way to making things easier to understand and easier to debug. Right? Modular code, good use of abstraction so that you can figure out which component has probably got the issue you're trying to deal with, and you're not jumping back and forth between 12 different pieces of code in 6 different functions in 6 different files. You want decent error checking embedded into your code so that problems are caught early in the process, right? If you've got data entry, you want to check that that is correct as soon as possible after it's captured. And that way when you're debugging, you're looking back and saying, okay, here's the piece of the code that's having a problem, here's where the data came from. Right? You can check things fairly quickly. Let's see. You want to make sure that inside your functions, inside your methods, when you get parameters, you're making sure that they are in a valid range. Don't just randomly trust that whoever's generating the parameters is generating valid values based on what you're expecting. It might be the case that when you write code, you write it assuming that, okay, whoever calls this function is going to do this, this, and this, so the data is guaranteed to be in the right form when I get it. And then later on, you find that there's another reason to call that function from someplace else, and in that place, the parameters haven't been set up correctly. The values haven't been set up correctly. So, inside the function, make sure you've got valid data. If you make a function call, then when it comes back, if it returns a value, check that value. Right? If it's got some kind of a status value that it returns, see what it is. Make sure that it's actually a reasonable value. Again, before you use something that a function gives you back or something that a function updates, make sure that it did something reasonable. Right? Initialize your variables. If you've got uninitialized variables, then some compilers will auto-initialize them to 0 or whatever it might be, and other compilers won't. And so your code might work in some places because that variable happened to be initialized to 0, or when run on some platforms, or compiled with some compilers, and then you compile it someplace else and it doesn't work because it's got some random garbage in that uninitialized variable. Think about checking array bounds, think about checking iteration limits, right? Make sure you don't have infinite recursion or infinite loops. Think of ways that you can embed things like that into your code. Right? So that all comes back to the idea of code standards, right? Writing quality code. So any of that eliminates a lot of the problems that you will otherwise spend time debugging. You want to make good use of tools, right? Have a decent editor that does good syntax highlighting for the language you're working with, does things like bracket matching, just anything that can help you search your way around, find potential problems. Anything that can do highlighting that brings up information about whatever kind of function you're on or whatever variable you're on. Anything along those lines that your IDE might do for you is going to be helpful. You want to make sure you turn on the warning and error options in your compiler or in your interpreter, right? So that when it goes through and compiles, it warns you about potentially problematic code. You want to get a good debugger, and you want to have an effective plan for using it. And we'll talk about that as a separate issue in our next session. So, a few basic ideas, right? When you're going through, you've got a problem, you've got a bug you have to try and fix and find, or find and fix. First of all, this is kind of comes back to the idea of bug reporting. Try and find a minimal set of steps to reproduce the bug, right? That gives you a better idea of what leads to the bug, potentially what causes the bug. It strips away some of the things that aren't relevant to the bug, which is also going to help organize things in your head. If you're having trouble just narrowing down what the problem might be, try explaining it to somebody else. Doesn't matter who. A friend, a coworker, your cat, whatever. It's that process of going through and vocalizing, expressing in some kind of ordered sequence what you think is happening that often leads to you going, oh, wait a minute, it's blah. So if you can go through and do that, it's not the other person that, it's not the listener that's relevant here, it's you going through and expressing the problem that often triggers something in your head that you wouldn't have thought of if you're just sitting there staring at the code. Now, that said, getting another programmer to look over your code is helpful. A fresh set of eyes. Often you'll sit and stare at a chunk of code for half an hour or an hour or whatever it might be, and somebody else will walk behind you and go, oh, you're missing a semicolon there, or oh, this bracket's off, or whatever it might be, or you've got a typo there. Right? That kind of thing can make a big difference. Even just taking a break, go outside, take a walk, have a coffee, whatever it might be, clear your head, come back with a sort of fresh idea, fresh perspective. Which brings us to the first of our stolen memes, right? The debugging tactics. I think this is pretty darn realistic for most of us when it comes to debugging. All right, what we know is probably a good idea to go through and try and debug something, and what we actually wind up doing anyways, even though we know it's probably not going to work and not going to help. However, let's see. I highly recommend the meme page on the CS Discord site. Let's see. In terms of narrowing down the problem, if you've gone through and you still haven't got an idea of where the problem lies in your code, one of the things you can do is to take the kind of binary search approach, where you go, this value is broken by the time we get to line 8,000, but it's still okay at line 4,000. So we say, okay, let's split the difference. We'll look in the middle. We'll look at line 6,000 and see if we can stick something in there to check if everything's okay at that point. And so you stick in a bunch of extra code, or you use your debugger to go through and look at the data values at line when you reach line 6,000. You go, if it's already broken by there, then you know the problem's somewhere in that first chunk. And if it's not broken by there, then you know the problem's probably somewhere in the second chunk. And you just repeat as necessary, narrowing down where in the code the problem might be. Again, just a general idea to try and figure things out, rather than just kind of sitting there going, okay, well, I'll start reading it through from line 1 to line 8,000 and hope that I recognize the problem when I spot it. Beyond that, it's usually a good idea to start coming up with kind of a few theories about what the problem might be. Right? Look at what's going on, what's going wrong. Look at if you go back to that idea of using the sort of minimal set of steps to cause the problem to take place, based on those steps and based on the nature of the problem, try and come up with a few different theories about what might be causing your problem. When you've got those few different theories, then say, okay, well, for each of these, can I come up with a set of data that will prove or disprove that theory? If my theory's right, then if I stick in these values, it should do this. And if it does something different, then my theory is probably not right. If it does that, then I've got a little bit of extra information. Oh, maybe my theory is right. And you can start pursuing that further. So you go with this sort of hypothesis and test idea, where we're going to come up with a hypothesis about what the problem might be and coming up with some test data to confirm or reject that. And if it doesn't work, you go on to the next hypothesis. Right? Just so that we've got some kind of ordered, structured approach to things. I strongly recommend learning a decent debugger, learning the features of it, getting used to working with it. Again, it can be a lot more effective than simply sticking a lot of print statements into your code, saying, okay, well, I'll print out the values of everything here, and I'll print out the values of everything on line 100, and I'll print out the values of everything when I get into function this. And I'll have a whole bunch of print heres in my code saying, oh, well, I got this far before it crashed, I got this far before it crashed. All right, make sure that you learn and use a decent debugger. So, again, there's a ton of different debuggers out there, all sorts of different price points, all sorts of different feature sets, but there's a few things that are pretty common. So one of the ideas is breakpoints, the notion of being able to specify a spot in the code where the program will pause for a moment and let you examine what's going on. Look at variable values, look at the call sequence, look at the parameter values. So most debuggers provide you with a means of setting and clearing breakpoints, saying pause when you get to line 7000 in this file, or pause when you call this function, or pause when the value of this variable changes. Most debuggers, once you hit one of these breakpoints or pause points, will allow you to look at what your variable and parameter values are. They'll allow you to look at values that are stored in different spots in memory, and maybe to tinker with them, to change them. If you look at something and say, well, this pointer should actually be null when I get here, set it to null, and then see if the program behaves normally from that point. And again, that gives you a better idea of what's going on. If something doesn't have the value you expect, stick in the value you do expect and see if that solves the problem. And if you do, then you're kind of confirming your idea that, it really is this value that's the issue, so let me work backwards from this point to figure out where it got messed up, why it's not having the value I expect when it gets to that point. Most of them will allow you, once you hit one of these breakpoints, to say, okay, let's go through one more instruction and see what happens next. One more instruction, see what happens next. Or eventually when you want to say, okay, resume running until you hit the next breakpoint. Most debuggers will also allow you to go through and say, okay, well, where am I right now? Right now I'm in function foo that got called from function blah that got called from the main function, or whatever it might be. So it allows you to examine the call stack and see which function calls and which method calls are active right now, and probably allows you to go through and browse what their parameter values are, sort of browse through the local stack to see what's going on at this point in the program. So those are all pretty common features, and they are very helpful if you use them with some of the other sort of investigative techniques we were talking about. So in our next couple of sessions, we'll go through and start playing with the GDB debugger, I can speak, and see how we go there. But we'll leave with yet another steal from the Discord page. All right, I will leave it there for now, and we'll pick up with GDB and debugging.